Second question. This question is of normal approximation to the binomial distribution. Here the continuity correction will be used. Anil is candidate in an election. Anil is a candidate in an election. He received 40% of the votes. A random sample of 120 voters is chosen. Use an approximation to find the probability that of 20 voters between 36 and 54 inclusive voted for Anil. Now, in this question, N is 120 because a random sample of 120 voters is chosen. N is 120 and vote received 40%. We have to find the probability that out of 120 voters between 36 and 54 inclusive, we will write 36 and 54 inclusive voted for Anil. So we will write this 34 and 54 inclusive mean we have to find the probability of X lies between 36 and 54 inclusive. Inclusive mean extreme values 36 and 54 will also be included. So data for this question is N is 120 because 120 voters chosen. P probability of success is 40%, that is we can write 40% 0.4. Q will be 1 minus P, that is 0.6. Now we have to find the probability. We have to find the probability that X lies between 36 and 54 inclusive. Inclusive means these extreme values also included. 36 and 54 we write it as less than or equal to. We will use this equality sign also. So first because use an approximation word is there, so we will make the continuity correction for first of this inequality. Continuity correction mean we will take the lower bound of this first value and upper value to the upper bound for this last value. So continuity correction after continuity correction this inequality will become X lies between lower bound of 36 is 35.5 and upper bound of 54 is 54.5. We have subtracted 0.5 from this value from 36 and added 0.5 in 54 we get this. Now equality sign will be removed after continuity correction. Now we will convert this x into z by the formula x is equal to z is equal to x minus mu over sigma. We will convert this normal variable into standard normal variable. So z will become x minus mu over sigma. First we will find the value of mu and sigma from binomial distribution. This is binomial distribution. We will find the value of sigma and mu from binomial distribution. So A formula for mu, a formula for mean is mu is mean is n into p. Here n is 120 and p is 0.4. We get mu is 48. In the same way, we will find a sigma square, that is n into p into q, n p q, n 120, p is 0.4, q is 0.6. We will find a sigma from here. We get sigma square root of this, we get sigma. So sigma will be 5 points after taking square root, 5.367. Now we will use this value of uh, mu and sigma here. X minus mu over sigma, 35.5 minus mu is 48 over sigma, that is 5.367. 54.5 minus mu over sigma. Now we calculate these values. We get calculating it, we get minus 2.329, and calculating this, we get 1.211. Now we will find the probability of this value minus probability of this value. So we can write probability of 1.211 minus probability of minus 2.329. So first we make this. This is the value of z. This is negative. We will make it positive by subtracting from 1. So we can write probability of 1.211 minus, we can write this term 1 minus probability of, now this becomes positive, 2.329. Simplifying, we get probability of 1.211 minus 1 plus probability of 2.329. Now we will take the value of probability of 1.211 and probability of 2.329 from normal distribution table. So we get the value of a probability of 1.211 is 0.8871 minus 1 plus probability of 2.329 from the table. Will we have this value 0.9900. After calculating, we get the final answer is 0.877. This is the answer.